Good afternoon, everyone. Today, let's see about exception handling in Java, a comprehensive guide. Welcome to this comprehensive guide on exception handling in Java. In the world of software development, unforeseen issues and errors are inevitable. Java's robust exception handling mechanism provides a structured way to manage these runtime problems, ensuring your applications remain stable, reliable, and user-friendly. This presentation will walk you through the fundamentals, best practices, and advanced techniques of dealing with the exceptions effectively. What are exceptions? Understanding the basics. It is core. An exception in Java is an event that disrupts the normal flow of the program's instructions. When such an event occurs, it creates an exception object and transfers control to the Java runtime system. This system then attempts to find an appropriate exception handler to deal with the problem. If no dealer is found, the program will terminate abruptly. Exceptions are a powerful tool for indicating that something unexpected has happened. Then they allow developers to separate handling code from the main logic, making problems cleaner and easier to debug and maintain. Definition: an event that disrupts normal program flow during execution. Purpose: find a structured way to handle runtime errors and accepted conditions. Outcome: if unhandled, lead to program termination. If handled, loss recovery. Types of exceptions: checked versus unchecked. Java categorizes exceptions into two primary types: checked and unchecked. Understanding this distinction is crucial for effective exception handling. Checked exceptions are those that are compiler forced you to handle. They typically represent predictable but unrecoverable problems such as IO exceptions and SQLs. You must either catch them or declare that your method throws them. Exceptions, on the other hand, do not require explicit handling at compile. These usually include runtime errors like null point exception or array index out of bound exception, which often indicate programming logic error and best resolved by fixing the code rather than catching the exception. Checked exceptions: compiler forced exception, inherit from exception. Examples: IO exception and SQL exception. Unchecked exception: no compiler enforcement, inheritance of runtime error or error. Example: null pointer exception, arithmetic exception. The try-catch block handling exception gracefully. The try-catch block is an cornerstone of exception handling in Java. The try block encloses the code segment that might throw an exception. If an exception occurs within the try block, the control is immediately transferred to the catch block. The catch block contains the code to handle a specific type of exception. You can have multiple catch blocks for a single try block, allowing you to handle different types of exceptions separately. This mechanism ensures that your program can gracefully recover from errors without crashing. Write risky codes. Place code that might throw an exception inside the try block. Identify exception. If an exception occurs, the runtime identifies its type. Handle exceptions. Control transfer to the matching catch block for processing. Continue exception. Program flow resumes through the catch try block. The final block, ensuring resource cleanup. The final block is an option but highly valuable component of try-catch structure. Code within the finally block is granted to execute regardless of whether an exception was thrown or caught in a try block. This makes it the ideal place for crucial cleanup operations. Common users for the finally block include closing file streams, database connections, or network sockets. By placing these operations in finally, you ensure that virtual resources are released, preventing source leakage and maintaining application stability even in face of errors. Grant execution. Code always runs even if an exception occurs or is caught. Resource cleanup. Ideal for causing files, network connection, and database links. Ensure proper resource delocation, improving application robustness. Throwing exceptions. Beyond catching existing exceptions, Java allows you to throw exceptions explicitly using the throw keyword. This is useful when you detect an error condition that your method cannot resolve or when you want to signal a specific type of problem. You can throw instance of standard exception classes more powerfully. Custom exceptions enhance code readability and allow you to define specific error conditions relevant to your application's domain. By extending exception or runtime exception, You tailor the error reporting to your exact needs, making debugging and maintenance best practices. Favor specific exceptions type over broad ones. Use unchecked exceptions for programming reports and unchecked exceptions for external problems that are out for your direct control but might be recoverable. Conclusion. In this presentation, we explored the essential aspects of exception handling in Java. From understanding what exceptions are implementing robust handling strategies. Mastering these concepts is fundamental for developing resilient and maintainable Java applications. Remember that good exception handling is not just about preventing crashes, but also about improving the user experience and simplifying